Hello future officers, I hope you're doing good. I hope you're doing fine. Welcome back to this channel. Another day, another topic that we would be decoding. And the topic for today is speed over ground and speed through water. A topic which most of the cadets find difficult to understand, but we'll break down things and we'll try to understand what speed over ground is, what speed through water is, and where are these two speeds used. But before we start off, I would like to quote Thomas Jefferson, who said, "I'm a great believer in luck. The harder I work, the luckier I get." So with this great quote, let's clarify ourselves with what speed through water is and speed over ground is. But before I talk about what speed through water is and speed over ground is, let's clear out our basics with what is the unit to measure speed at sea. The unit at sea and in air, the unit is knots. 1 knot is equal to 1 nautical mile per hour. Now the question is, what is this 1 nautical mile? 1 nautical mile is nothing. It is 1 minute of the 1 minute angle from the center of the earth. If I have to tell you, considering that this as a big globe, okay, now I know my diagram is not right. This is the earth, okay, from the center. If I draw 1 minute, this is 1 minute. 1 minute, okay, it's 0 degree, 0 degree, 1 minute. So if this is 1 minute, okay, the angle is 1 minute. So if I have to measure it in kilometers, how much is distance from this point to this point is 1 minute. It can be anywhere from this point to this point. This angle can also be 1 minute. So I'll be measuring distance between these 2 points in kilometers. So this is 1 nautical mile. This is 1 nautical mile. If you see 1 minute arc at the center of the earth, it is not generally measured at the from the equator plane or anything. It is just a 1 minute arc, and that is one thing that created the problem. Now, since we all know that earth is not a perfect curvature, so the distance as in when we go from the equator to the pole, the curvature reduces at the pole. So now with the curvature reduces at the pole, the distance does not remain the same. At the near the equator, the distance is different. When we go toward the equator, the distance is different. So because of this difference in distance, we got a standard value of 1.852 kilometers, or you can also add 1852.3 meters. Since the earth's curvature was different, is not same, the distance over here came out to be 1842.9 kilometers or 1.8429 kilometers. And somewhere over here at the poles, it came out to be 1861.9. It is not 9, it is 7 over here. This is 1.8427. It is 1861.7 meters. This is kilometers. So let us keep it straight. At poles, it came out to be 1 minute came out to be 1.8619 kilometers, and at the equator, it came out to be 1.8427 kilometers. So you can see the variation, the amount of difference. So for this reason, we got a standard value of 1.852 kilometers. Okay, you don't have to remember this thing, you just have to know what is the value of 1 nautical mile in terms of kilometer. So now we know knots is 1 nautical mile per hour. Okay, 1 nautical mile per hour. Okay, example 10 knots is ship moves at 10 nautical mile per hour. So both STW and SOG is measured in nautical mile in knots. Okay. Now we'll start off with what speed through water is. Speed through water is actually the speed of the ship in relation to the water around it. Now, since both STW and SOG are measured in knots, but their reference point are different, that what makes these two entities different. The speed through water is generally the speed with respect to water around it. Okay, you can see ship's speed relative to the water around it. How fast, like how fast is the ship moving with respect to its water? Once you have stopped engine, the ship is stationary. It is not moving anywhere with respect to the water. But with respect to the ground, the story is something else. But with respect to the water, it is not moving. It is still where it has to be. Okay. So if you understood what I said, if I have to keep it this way, that if the ship is not moving, it is still with respect to the water, that means the speed through water is 0. Speed through water is speed of the ship with respect to water surrounding it. Okay. Now what controls the speed over the ship? What controls? The engine RPM. Okay. How fast, what is our ship's propeller shaft RPM, propeller efficiency, okay, hull resistance and fouling, okay, sea state, waves, wind, vessel trip, all of these things affect the speed through water. Now how is it measured? The Doppler law, electromagnetic law, and then the impeller paddle log. This I don't know about this thing, but I've still mentioned it. And the key point is, the log is something which measures the speed of the ship, the speed through water with respect to the water passing through its hull. Okay, how speed the water is passing through the hull of the ship, speed log measures it. So if I have to keep it straight, the speed through water is the speed of the ship with respect to the water surrounding her. Okay. Now comes the speed over ground. What is the speed over ground? As I said, speed through water, I said the relative speed they are comparing, like the speed through water is relative to the water around it, but the speed over ground is not relative to the water around it, but it is relative to the ground, to the seabed. How fast is the ship moving in respect to the seabed? If you see, how fast are we actually moving from point A to B? Ship speed related to the earth's surface. Now earth's surface is what? Seabed. In this case, even if the vessel is stopped at some point, I have stopped the vessel, the current and the wave on the wind will push the vessel to some direction. Instead, at that moment, she is not moving in respect to the water around it, but she is moving with some speed in respect to the seabed. Okay, so it is measured by GPS positioning. And I said, why GPS positioning? Because for GPS, he does not know if there is water or anything. He does not know. GPS does not know if there is any water or anything. So GPS will tell you the speed of the ship, speed over ground, okay, ground oriented logs, integrated navigation system. So whenever you are on board ships and you need to find out what is the speed over ground, you go to GPS, global positioning system. And the reason it is why we GPS determines speed over ground, because for GPS there is no water. For GPS, it is all the solid earth surface. Okay. But for speed through water, we go to Doppler log, electromagnetic law. Okay. So this is for GPS, ground and the integrated navigation systems. Okay. Now why it is important? Why speed over ground is important? For ETA calculations. For ETA calculations, distance made good, passage planning, position fixing. Why do we need speed over ground over here? I'll tell you. Because we are actually covering distance. We are covering distance from point A to point B. How far, how good are we making with respect to the wave has nothing to do with the distance that we will have to cover. Okay, it can be in some case. Okay, in some case it could be like our vessel is moving and we have to reach somewhere over here. Okay, if we are going through speed over water, if we stop our vessel at this point, she will do 0 speed over water to reach over here. But if we give some current, some push, she'll be doing some speed with respect to the seabed. With respect to the seabed. I hope I am making myself very clear. If you have any doubt, you can mention in the comment box. I'll love to answer that. But speed through water is with respect to the water around it. Speed over ground is with respect to the seabed. Okay. To give you a clear picture of it, let us consider this ship. Okay. She is covering this distance. Okay. With speed of 10 knots. With speed of 10 knots. Let's assume she is covering a distance or speed of 10 knots. Now, we'll break this thing down. Now, we observe that there is a following current of 1 knot. there is a following current of 1 knot. Okay, so now what it is actually, this 10 knot speed becomes the speed over ground. And if, for example, if we remove this speed through water, no, not speed, this current, if we remove this current, we are just taking into consideration the ship's speed. So this will come down to 9 knots. 9 knots. You getting what I'm trying to tell you? She is going like this. She covered this distance in 10 with 10 knot speed. Now we discovered that the waves are pushing from a stern, or wind is from stern with 1 knot speed. So we discovered that this is the SOG. But now what is this speed through water? Is when we remove this current. Now we get speed through water, that is 9 knots. Getting me? So I hope I have made myself clear with this particular example. Okay, we'll be solving more example in the coming slide that will make things better for you. Now there are 3 layers which operate at sea. One is the ground, its extreme seabed. Okay, and then there is this extreme seabed, the ground. Then there is water mass, and on top of that we have the ship. So these are 1, 2 and 3 layers. Okay, speed through water relative to ground, and speed relative to ground is speed through water is relative to water, and speed over ground is speed relative to ground. Now let's clarify our doubt. Okay, how it is. First we'll take into consideration that there is no current. Okay, we'll take into consideration that there is no current. Our speed through water is 12 knots. Okay, speed through water is 12 knots and there is no current. So if we are not supported by the current or anything, the speed over ground becomes 12 knots, because no current, no wind, no waves. So speed over ground is equal to speed through water. Whatever distance the ship is making over the water with respect to the water around it, she will be making the same amount of distance with respect to the seabed, because there is no current available. Now we have following current. For example, if you can see in this diagram, for example, if the current is coming from this direction, I'll change the color of the pen, I'll make it red. I hope you can see. If the current is flowing from this direction, now the following current, let's the speed through water is 12 knots. Again she is doing speed through water 12 knots with the help of her engine RPM. Okay, and the current discovered was 2 knots. So now the current is coming from behind, so automatically the current will be pushing the ship. So the current will give additional 2 knots boost. So what speed over ground will become 14 knots. Now with the help of this 2 knots current, the speed over ground becomes 14 knots because of the additional push by the current. Now let us consider the poor ship has a head current now. Now the current is coming from this direction. Speed through water, whatever the engineers on board are doing is 12 knots. We are making 12 knots according to the ship's RPM. But now we are being pushed from the forward with 2 knots speed. Again 2 knots speed. So you tell me, if I am pushing you from forward, if I am not allowing you to go ahead, will your speed increase or decrease? It will decrease. Now our speed with relation to the ground will go down to 10 knots, because the current coming from ahead is of 2 knots and the current, the speed our ship is doing is 12 knots. So it will go down to 10 knots. The SOG will come down to 10 knots. Okay. So in this case we have speed boost, but over here we are burning fuel, more and more fuel, and losing ground. And now the fourth scenario is the current is coming from this direction, a beam. You see, beam current. Speed through water is 12 knots and current is 2 knots on starboard side. This is her starboard side. So there won't be much of difference in the SOG and COG, but there is something known as heading and course over ground. They won't be the same. See the track drift away COG. This is heading. This is heading. Because the current is pushing her over like this. Okay. She is going like this and the current is pushing her over like this. She is looking at this point, at this particular point. But bodily she is moving like this. she's moving like this. With respect to the ground, she's moving like this. Her eyes are at this point, but with the push of the current, she's moving like this. So this is course over ground. Again, course over ground is with respect to the seabed, and heading is with respect to the water bodies. With respect to the water bodies, she is looking ahead, and when the current is coming, she is going bodily moving this way, earthward direction. Now, where are these two things applied? Now we know what speed over ground is, speed through water. Even if there's some doubt, you can mention in the comment box. I'll cater the doubts. But now we'll find out where do we use this speed over ground and speed through water. What speed through water uses? Engine performance, RPM versus achieved speed. Okay, as I said initially, the engine performance, how well is our engine doing? We know through the speed of speed through water. Hull condition. Why I'm talking about hull condition, if there are too many barnacles attached to your ship's hull, automatically it will slow down your ship's speed. It will automatically slow down your ship's speed. How do we get to know? We get to know through our speed through water. We have a chart which talks about, if we are doing at this RPM, how much speed our vessel should do. But if our vessel is not doing that speed, we know, okay, there's some problem in either in our engine, or there's something attached to our hull which is slowing her down. Fuel optimization compared with SOG, this is something, fuel optimization is how much fuel should we use, which is the right amount of fuel we have to, what is the right amount of fuel for this passage, we can also get through speed through water. Maneuvering, stopping distance calculation. Why am I talking about maneuvering and stopping distance? Because all of these things are done with respect to the water, not with respect to the land. Okay, we don't take land for stopping the vessel. We consider the water around us because we are on water, not on land. Okay, and next is collision avoidance. In cold wrecks we don't follow speed over ground. In cold wrecks we follow speed through water. Okay, likewise in cold wrecks, if you go through rule number 9, it talks rule number 10, traffic separation scheme, it talks about crossing the traffic separation scheme. It should be at heading of 90 degree to the direction of the traffic separation scheme. It does not talk about course over ground, it talks about heading. So that is why heading in speed through water is important for collision regulation. Now we know about speed through water. Now we talk about speed over ground. What speed over ground is done? ETA calculation, what port pilot needs. Okay, all of these things are taken under consideration by speed over ground. Passage monitoring, distance, because why we are taking this into consideration, because by sailing direction, okay, ocean passages, we know what all currents and what all from where all direction, from all the weather routing charts, all the meteorological information, we know that how much of current we might get at this particular point. So with help of that we can use ETA calculation. Okay, we know things. Passage monitoring, also for passage planning. Position fixing, ARPA AIS target. Why ARPA AIS target? Because they are generally not too sea friendly. They take ground into consideration, just like GPS. Navigation and time planning, we use SOG. Engine and hull performance, we use speed through water. Now, what deck cadet should do? What do people should do as a deck cadet? Monitor instruments, GPS, ECDIS, AIS. Through this, we get speed over ground and course over ground. And from Doppler log and EM log, we get speed through water. Okay, these are the equipment. Now we compare values. Now we get speed over ground and we get speed through water. We compare values, and with the help of that, we determine whether the current is supporting us or opposing us. Okay, and with that we can estimate current. If our speed through water is 13, SOG is 12. So it is, and the heading is similar. No, heading and speed course over ground is similar. So we know that we have an opposing current because our speed over ground is less. You see, to add head current, the current is coming from our head. Now speed through water and speed over ground. Speed through water is 12, but our speed over ground is 14 with same heading and course over ground, which means we have got 2 knot of following current. That means we are being pushed. And record and report. Okay, we have to enter in the logbook, passage notes, officer's report, and all these things. Don't just copy numbers. Know the reason for what are we doing and why we are doing. So I hope you understood all these things. I hope I have made myself clear. speed over ground and speed through water. If there might have been any mistake in explanation or something I might have done wrong, you can always mention in the comment box. I would correct myself. I would accept my mistake. Okay, but whatever the difference between speed over ground and speed through water is, I have mentioned quite clearly, and I've tried my best so that you understand what speed through water and speed over ground is. Speed over through water is actually the speed of the ship with respect to the water body around it, and speed over ground is speed of the ship with respect to the seabed. Okay, so if there's current and the ship is being pushed, and the speed that we get is speed over ground, but if the ship is going with respect to her own ship's RPM and engine, that is speed through water. Okay, so this we have, and the Merchant Navy Decoded has launched this package, Decoded package, which is for deck cadets who are in their pre-C and they are going for a company interviews, those who are doing BSc and cadets who have completed their pre-C training and they are waiting to go on board ships. This package is your lifesaver, because on board ship there are two aspects. One is the practical, one is the theoretical. Practical, as in when time passes, you will get hold of that. But theoretical, this package is your lifesaver. Coordinated by Captain Arun Gupta. And also, if you want to know how a deck cadet works or what a deck cadet should do on board ship, we have posted a video on what a deck cadet does. You can go into our channel and find out what a deck cadet should do on board ships. And if you like this video, do share it, do like it, and also take trial for this package on merchantnavydecoded.com and find out how good this package is. And at the end, I would just like to tell, this is our social media handle, and I post quizzes on this particular Telegram channel, and whatever notes of this particular page is, particular video, I'll be posting in this page, Deck Officers Decoded. If you do like the video, do like and share. Till then, we'll meet next time.